today's webinar, which is 5 ways to detect malicious activity and protect your Kubernetes and cloud workloads. And of course, today we'll have our speaker, Manoj Ahuje. Well, before I hand things over to our speaker, we have a few housekeeping items that I'd like to cover on both this presentation and the webinar platform in general. So first off, today's webinar will be made available to you on demand after the live session finishes. Expect the on-demand version to be there around 15 minutes after we end the presentation. Copies of today's slides can be made available, but you have to request them from us, and you can do that at contact@tigera.io to request your copy, or you can just go into the website and fill out our contact request form. You can also reply to any of the emails that we may have sent you from Tigera. And that email is reply@tigera.io. But if you just reply and say, I'd like the slides, we can take care of that for you. So most importantly, though, we'd love to hear from you during today's presentation. This is an interactive kind of thing. If you have questions about the content for our speaker, please feel free to send those through the BrightTalk interface where you can ask questions. We will, if Manoj feels that the questions are relevant to what he's talking about at the moment, he will answer them. If not, we'll save them for the end, where we will have an extensive Q&A session. This webinar is scheduled to go an hour, but we have the capability to go into an hour and a half. So we will not run out of time for questions, that's for sure. So today, what are we covering? What's the background? Why are we talking about protecting your Kubernetes workloads? Well, Kubernetes adoption and overall cloud, the complexity of the cloud is really what's driving it. There's this mass movement of applications to Kubernetes and to the cloud, and increasingly those applications are mission critical and also internet facing and public. So why move? Well, you guys know that the cost reductions, the ability to accelerate deployment, and also improve efficiencies and scale that Kubernetes and the cloud bring you are clear. But the dark side of that is that 70% of the security and platform people that were interviewed in a study found it more complex to manage privacy and data protections when using a cloud environment. So the net is that security teams struggle to establish a strong security posture with both of these situations, with Kubernetes and in cloud environments. And we've gone over in past webinars why that is. I would encourage you to peruse through our BrightTalk webinars. You'll see a lot of great content on why Kubernetes and cloud environments are difficult for security to manage, security teams to manage. So with that background, let me introduce to you our speaker today. So today our speaker is Manoj Ahuje. Manoj is a threat intelligence research engineer with Tigera. He's a subject matter expert on vulnerability research, malware reverse engineering, and exploit development. He has extensive enterprise network security knowledge and experience, and his previous roles include covering these areas for both Juniper Networks and Intel. So without further ado, I would like to hand it over to our speaker, Manoj, and our presentation today. Manoj?
Hi, good morning, everyone. So today we're going to look at the cloud infrastructure attack, where attacker compromises multiple workloads in your cloud infrastructure and tries to move laterally. And we will be detecting those lateral movements with global alerts. At the same time, we will look at malicious activities and many anomalies and how to detect them with global alerts. So let's look at today's attack scenario and how we have our infrastructure set up. So today we have our enterprise site running in Kubernetes, and it is exposed to internet on port 80. It runs on in the default namespace, and it's a Drupal application on the running on the default namespace. At the right, we have ground space where our critical business workload is running. It is Webmin, and Drupal is kind of pulling data from Webmin to show it to our front-end users. So this is the setup we have right now, and we will be configuring our global alerts around these two workloads. So let's look at them how. So first of all, we want to talk about current approach to policy. So most of the application in cloud environment end up categorizing as they end up being categorized, and policy is usually applied to that particular category or that particular label. But imagine if the pod is created and the particular label is missing on that. So what happens? It may have unlimited access into your cloud. So that's how the policy gaps are created over the period of time. So imagine your business critical web application. So that sort of application, when it starts listening on port and someone connects to it, the case like that, this cannot be monitored. Also, when the business critical application starts communicating with someone which is not intended through policy gap, I want to know that. So these are the cases we're gonna target in this presentation for lateral movements. So what we want to know here from our setup. So we want to know when our Drupal application, which is the front-end enterprise application, it talks to a resource inside a cloud apart from Webmin on port 10,000. I'm sure I want to know that. We want to know if my critical business application Webmin starts talking or initiates connection. I want to be able to know that. And what happens if Webmin starts listening on a port and somebody connects to it? And being a daemon, Webmin just should listen on port 10,000. So I want to be able to know that. Second thing which is important in cloud environment is metadata and cluster API. If it is being accessed through your user namespace, that's really suspicious unless and until your developer has specifically written some code to access the API. Those APIs won't be accessed through pods or through your workloads. So if somebody is trying to access it, I want to know that. Also, we would be configuring our suspicious IP and domain name threads through our thread feeds feature, where we can import the feeds, public feeds, or you can have your own internal feeds. Those can be useful. And the next thing we will target is if there is any DOS or DDoS attacks. Well, we want to be able to know that. And this is a really easy configuration with Global Alert. And the policy monitoring is something really critical. You want to know when your cluster is running. If there is somebody who is, what happens in large enterprises is you have many admins and many roles, and someone who is not supposed to make changes gets the administration or SA account with the privileges and starts making changes. So I want to be able to know that if somebody in your cloud environment starts making such changes global network policies or network says. So this is the thing we'll be looking with global alerts. And last but not least, DGA traffic. So if you, this is like the top IOC, if your cluster sees DGA traffic, it's almost like it's compromised, and this is this is something we will be talking about in future. So in this demo, we won't be showing that, but in future we will have a blog post for that. So with that, we will start with our first demo of lateral movements. So here, this is the attacker machine, and this is simply, I'm trying to see what is the public enterprise site looks like. So being an attacker, I don't care about the GUI. I'll just go ahead and make a request to the application, and here I can see the headers, HTTP 200 OK request, and in that header I can see the deployment which is running there is Drupal 8. So Drupal 8 is interesting. So if we do a little bit research on Drupal 8, if we do a little bit of research on Drupal 8, we can see that the Drupal 8 has form API injection. This injection works in a way, the Drupal has API where if we inject any input in the form, it accepts and stores it. But when there is a callback and that malicious input is an array, the values inside the array ends up executed. So that's the vulnerability we are targeting, and a little bit of research attacker discovers there is a Metasploit module available as well. So we will use that module to do the further attack. So let's look at the attack. So here, attacker just firing up the console, and I'm gonna set the Metasploit's parameter to just Drupal site. We're targeting Drupal site, and we will try to exploit it. So let's exploit it. Okay, so we see the session running on Drupal side. Yeah, we will go ahead. And I will drop to shell, and I'll see that the user I am is with UID 33. This isn't I'm looking for, but I'm happy with any kind of access. I would like a root, but it's fine. And I'm running as application process, which is www-data. And we will, I think the most interesting file to look at is the service token here. So we will look at what we can do with service token later, but at the same time here is the service token. So attack is successful on Drupal. Now we will see how did we do on detection part. So we will. So think about these manifests are they run once in 10 minutes. So they will look at the window for 10 minutes, and they will run once in 10 minutes. So I'll show that in configuration briefly, but just here we will just execute it right away because we don't want to wait for 10 minutes for now. And let's fire up, and the manifest is successful. So let's look at the alert. So we see a lateral movement detected alert, which says the outgoing connection from Drupal. So as soon as the Drupal initiated a connection to a known host, the global alert came in and said, hey, your Drupal application has initiated a connection which is not approved or authorized. I think we had some trouble with our security. All right, looks fine. So as you can see, the lateral, as you can see, the alert, the global alert told us, and we can go and further investigate this. So that's about the Drupal attack. Let's go back to our slides. Yeah, so this is the manifest we use to configure alerts. The interesting thing to look at is the parade and look back. So both are set to 10 minutes. As I said, these manifests run every 10 minutes, and they look at the data, which is T minus 10 minutes. So this is what it is. And the query is another interesting part to look at. You can be really creative here. And this is what it looks like for outgoing connections from Drupal. The same way we have queries configured on Webmin. If Webmin initiates any connections, as being a service, we are not expecting any connections being initiated from Webmin. But if it does, we will see alert for that. And the same thing for Webmin is, if this is my business critical application, so if it accepts, if it starts listening on any port, so I'm gonna know using this particular manifest. So these are my manifest. So, and this is the alert we saw for the Drupal. So we want to move to next phase of attack. So let's look at my screen. So here we have session running already that we compromised Drupal, and we would want to know what is there which is accessible inside a cluster. So there might be a lot of resources which are running in your cluster, in any cluster. So basic way will be to ping sweep the network or do the port scanning. So here I'm going to use the ping sweep method, and I will sweep the /16 network. It takes a lot of time to sweep it, but listen, attacker is in no hurry. He can wait for months in there. So we will sweep the network, and here we found few hosts. So those hosts, after probing to each one of it, attacker finds out that there is a Webmin service which is available on port 10,000, and now he wants to probe it further and see what's going on there. So we go to our Drupal session again, and we drop to shell so that we can query our Webmin pod, which is accessible from Drupal. And notice that Webmin is not accessible through internet. This is totally your business critical application. So we're gonna go ahead and make a request to Webmin and see what's going on there. So here we make a request, and we see a lot of data. So this is clear to me. This is SSL, and I see 200 OK response, so that's good. And I see the server header as well. So this is miniserv 1.910. So let's see what is miniserv 1.910. And we little bit of research on 1.910. It kind of comes to us that there is a problem with this version. So this version has a backdoor in its code, and this is the second time it has happened for miniserv that attacker was able to successfully put backdoor directly into the code. So this is interesting. And backdoor is simple. When you go and change your password, you put your new password and then your old password. So whatever you put inside your old password, it gets executed. So as simple as that. And we have a module for that, and we will use it to exploit. So let's look at it. Okay, so here we go. So here now attacker opens another shell to the Drupal, and we need two shells here because we need one shell to just listen for reverse shell if we successfully compromise Webmin, and another shell here we want to be able to send or exploit to our Webmin. So we have two shells open here. We will go ahead and drop into one of the shells. And I already put some binaries there which we can upload to Drupal. We have access to that. So used one of the binary to listen on particular port 2222. So this is what I did. I went in and now started listening on port 2222. On second side, this is a little bit interesting. It gets tricky in cloud that your destination is not reachable to attacker. So I'm going to create a relay. So what the relay will do is any traffic it gets from my attacker machine, it's going to forward to Webmin. And this is as simple as one command. So on my machine, if I send anything on port 5000, it's going to go to Webmin on port 10,000. And this is being done through Drupal. So we set that up, and now we'll go back to our console and we'll exploit Drupal by setting the proper parameters. So this is console, and we set up the parameters, and we will try to exploit it. Let's give it a try. And yay, as you can see on right side of the right side, you got a console running, and it's UID 0. So we got a root access on Drupal, and we will look at if anything else we can look at is always the default token. So we will look at that. Yeah, so we compromised the Drupal Webmin service now, and we have access to the pod, root access to the pod. Here, the attacker can really use this as a mining pod because he has the privileges, or he can use it as a further pivot to launch attack into your cluster. So it depends on attacker. But right now we will see how we did on detecting this attack, and we will just go and quickly execute our manifest because we don't want to wait for 10 minutes right now. And as soon as we execute, let's see. And yes, we got an alert. We will go to our Calico Enterprise Alerts UI and have a look at it. So we see the Topman outgoing connection from Webmin, and this is the connection we are looking where the Webmin, the workload has kind of initiated the connection while we were monitoring it, and now we are seeing it. So we can investigate further to see what's going on there. So this is about Webmin. Let's move on to our slides. So as you can see, the manifest we use there, this is the alert we already saw. So now we come to the cloud API access. So this gets interesting, as I already talked about it. Whenever you see probing to cloud APIs, as data center is completely API driven, you would want to know that. So we will look at the quick demo here. So here I already have our Drupal shell, so we'll just go into it and use our binary. We will just we would want a kubectl binary here, so we will go and download that binary and see what we can do with it. So interesting thing about kubectl is it automatically detects the service tokens that we have, default service tokens, and everything it needs to run. So we don't need to do any extra configuration. If you have that binary and running privileges, we can do that, and we can run the kubectl to know what are the privileges our token has. So we will go ahead and run that. And this is the simple command, and it tells us what are the privileges this token has. So from the looks of it, we don't have edit privileges anywhere, update or patch privileges. So only a self-subjective, that is nothing. So basically the default token doesn't have any interesting privileges. Though the token doesn't have interesting privileges, attacker tried to access the cloud API. So we're gonna go and execute our manifest, which is monitoring the cloud API, and we will see it run successfully. And we go to our enterprise secure alerts page, and let's see how the alert looks like. So this is the alert we got that somebody from your user space, he doesn't have any business to be querying API, and these are all the details you get. So this is the metadata API access. Whenever you try to query it, you can monitor your metadata APIs like etcd and RBAC. So we can monitor any cloud API with this. So back to our slides, and we saw this is the manifest which was triggered. So interesting fields to look at again is period and look back, and the query itself. So sometimes it looks complex, but it's not. You can be really creative with these. So you can look at our blog post which we did on these. So you'll get a better idea on configurations. And this is the alert we saw. And now the suspicious IP and domains. So this is really a quick demo. So let's look at our suspicious IP and domain feeds. So here we go again, back to our back to the session on Drupal. We're gonna go and just interact with it. And what I'm gonna do is, while I'm on a shell, I'm just gonna pick a bunch of IPs from suspicious IPs and domains, and I'm gonna talk to them. So if so here it is. I just started talking, and as soon as I start talking to this bunch of suspicious domains or IPs, you can see that I didn't use any of this in my attack, but attacker probably or one of his tools ends up talking to these. So you will get an alert if you have this configured suspicious IP and domains. So we will look at the alerts here. You don't need to run any job, as this is as soon as you make a query suspicious IP, as soon as your workload tries to talk to any suspicious IP or domain, you will see the alert by default. So let's see how it looks like. This looks like the workload has tried to talk to a domain, and this is how it will look like for a domain. And we see it is wcrack.com. And if workload tries to talk to an IP, so this is the alert for the IP. All right, so back to our slides. So as you see, the I didn't use, so we already talked about it. And this is the manifest that we use. The suspicious domains and IP is really easy. We have pull methods. You just need to specify what are your feeds you want to configure here, and we will be configuring it for you. The same thing for IPs. And this is the alert we saw. DOS and DDoS. So if you are hosting a really sensitive service which can be DOSed, or you want to monitor the DOS and DDoS, it's really easy. We can detect the TCP, UDP, and DNS-based DOS. So how we will detect it? Let's look at it quickly. Let me go back to my screen. Okay, here we go. So this time I'm an attacker. I'm just gonna go and grab this particular, my resolver script, and just make 1500 queries. And in very short time, so as soon as I am done with it, I should go to alerts page, and this kind of so this is interesting, as in 10 minutes time, as we configured our manifest to be running in 10 minutes. So it aggregates all the DNS requests it gets over the period of 10 minutes. If you want it to be shorter, you can make it shorter, like in 5 minutes. And it depends, the number depends on your cluster. The threshold depends on your cluster. So if you have 100 workloads, the number will be different. If you have 1,000 workloads, the number will be different. And if you have only 10 workloads, the number will be different. So that's why I kept it open-ended and took a really small number. And the number for me was 1,500. So we see alert. So if somebody is trying to DOS you, you will know immediately. You won't have to do, you can take straight away action of blocking the DOS. This is the configuration. As we know, we can configure it to be TCP, UDP, or DNS based, however you want. One of the interesting things is policy monitoring, because in policy monitoring, this is critical. Your policy is everything in API-driven data center. So if you are really paranoid like me, I would want to know each and every pod which is being created and who is creating them. And if not, then I would trust my admins, and I will definitely say these are the admins which are authorized to make changes. And if apart from them, anybody in large enterprise gets the privileges or uses privileges and starts patching or deleting or updating the pod, I want to be able to know that. So this is the first one. So we will create the global alert configuration around this. And second is, I want to know if my global network policies, if somebody is trying to create, update, delete, or patch them, trying to create whole or anything apart from my authorized service accounts or admins, then I want to be able to know that. So same with the global network sets. And these are the things we can easily configure with global alerts and monitor for your policy changes. And to do that, the manifests are really simple, and we can use make use of it. So this is policy monitoring. I don't have a demo for it, but this is really straightforward. So thank you very much. That's all we had. So with the monitoring spectrum, the features we have and the monitoring spectrum we have, and with the context inside the cluster and outside the cluster, the Calico enterprise is kind of in unique position to hunt the threat. So this is a threat hunter's paradise, I would say. And yeah, so you would like to test it out.
Yeah, thank you, Manoj. So before we get to the questions today, and we have a few questions actually, and feel free to type them in. There's about a 20-second delay before we get them, so go ahead and type them in now. I'd like to tell you a little bit about some of the other featured resources we have. In our Bright Talk channel, we have these two webinars which are of specific interest, but we have some great best practices around Kubernetes security webinars. Check those out. But these two in particular, the last webinar we did was another threat detection and mitigation webinar. It was around the anatomy of a specific Shopify attack and how to defend your infrastructure. Of course, this is applicable to a lot of different situations, and it's a really good webinar. Also, we have, which happened a couple months ago, one of our most popular webinars ever, which was understanding and troubleshooting connectivity issues with our head of solutions architecture, Karthik Rocker, which is a really great webinar, dense, packed with technical information. So I would highly encourage if you'd like to learn how to troubleshoot Kubernetes to go watch this webinar. And they can be viewed both on our Bright Talk channel or on our website. So I have a couple questions that have come in. So let me, Manoj, I'll read two of them to you. So earlier on, with the attack on the web admin server, it sounds like the attacker had remained hidden and undiscovered for quite a long time. Attacker dwell time has become an important issue for our company. These actors can cause a lot of damage. How are we able to uncover actors like this and reduce the attacker dwell time?
So for reducing the dwell time, this is what we are targeting with global alerts, how we can reduce the dwell times. Having a 10 minutes window, it really gives us that sneak peek and what's going on live with your Kubernetes workload. And if you configure your global alerting around your workload really well, you can in no time uncover the attack if it is compromised or if there's any activity in the workload. So this really reduces, that's why we have taken the window so short that dwell time is almost negligible. So.
Okay. You know, I mean, I have one question on that. You know, I'm in marketing, not a tech person, but I know when I set things in marketing with alerts, usually we like to have some kind of threshold, right? So because we get false positives sometimes, happens. So to avoid those, do we have something that addresses that ability for thresholds of alarm? So with global alerts or not?
Sorry, can you repeat the question?
Yeah. Okay, so are you able to set thresholds for alarms so that you don't get false positives or you minimize false positives potentially?
Yeah, actually, these alerts are pretty configurable, and the false positive could be there, but if you configure it again right, so this is a crafty tactic that whoever is configuring will have to use and make it really tight so you don't see any false positive. but according to, if you asked me, you can be at 0 false positive as well.
Okay. Another question we had, I know that Tigera, in past webinars, we talked about the amount of metadata that we actually add to log files. The typical log files you get from Kubernetes, actually, if you're running Calico Enterprise or Calico, you actually get a lot more information in the log file. So you can view these log files both through going into log files or through the GUI, right? Our Calico Enterprise interface.
Yeah. Yeah.
Yeah, and you can export them to any program you want to analyze them, right?
So these logs files can be analyzed directly into Calico Enterprise. You don't need any other program or something like that. You will get a specific dashboard for specific type of logs that you're looking at, and you have those dashboards are really configurable. Those are means actually I use them in my threat hunting research. So it's really searchable, I would say.
Yeah. Okay. So the answer is yes. Okay. Okay. Well, Manoj, thank you so much for your time and for presenting such a great webinar. Thank you guys for the questions and for attending. So with that, I will give you some time back, and we can all have a great day, hopefully. Okay. And enjoy your day, and also remember that this webinar will be available on demand in about 15 minutes. So in case you missed anything, you'll be able to go back and rewatch it, okay? So thank you for coming, and goodbye.
Thank you. Bye.